Welcome students to today's session. After doing the two laws of chemical combination, we are going to make an explanation to these laws. This explanation was provided by British chemist John Dalton, and he provided the basic theory about nature of matter. And Dalton chose the idea of indivisibility, that atoms cannot be divided further. His theory was based on both the laws of chemical combination, the law of conservation of mass, and the law of definite proportion. So, what were Dalton's laws or atomic theory stated? Let us have a look into it. Dalton stated that matter is made up of tiny particles called atoms. Atoms are indivisible and cannot be created or destroyed in a chemical reaction. Atoms of a given element are similar in mass and properties. Atoms of different elements have different masses and properties. Atoms combine in small whole number ratios to form compounds. In a given compound, the relative number and kinds of atoms are constant. So these were the postulates of Dalton's atomic theory. This has to be studied. Now, what is an atom? Atom is the smallest particle of an element that may or may not exist independently and retain all its chemical properties. Atoms are very small in size, smaller than that we can imagine or compare. The atomic radius is measured in nanometers. 1 nanometer is equal to 10 into minus 9 meter. Or 1 meter is equal to 10 raised to 9 nanometer. The atomic radius of an atom of hydrogen is 10 raised to minus 10 meter. The radius of molecule of water is 10 raised to minus 9 meter. It is 1 nanometer. So that is the size. It is highly negligible, highly small. Now this Dalton's atomic theory suggested that atom cannot be divided into smaller particles. Later on we are going to look into the fact that atom is further divided into smaller subatomic particles. So this is about atom. Now let us see the symbols of different atoms that we are familiar with. The symbols of elements are represented by letters. The symbols of elements are represented sometimes by a single letter and sometimes by two letters. That happens when, see for example, aluminium is starting with A, argon is also starting with A, gold is also starting with A, silver is also starting with A. So we cannot have with the first letter of the element. So it is substituted with another letter. For gold and all, it is the Latin name letter that is taken, gold and silver. So sometimes it has got two letters. If a symbol has only one letter, it is written in capital letter. If a symbol has two letters, then the first letter is in capital and the second letter is in small letter. So this is a list of some of the common elements that we come across. You have to learn the symbols of all these elements. So this is a work for you. You will take out your practice book and write down the names and symbols. They have to come to you automatically because you will be writing down equations with this. So these symbols are to be learned. Now let us go into the concept of atomic mass. Since atoms are very small in size and the mass is very small, Determining the mass is very difficult. So mass of the atom is compared with the mass of a standard atom. The atom which we consider as standard atom for comparing the masses is carbon. Carbon 12 atom, because carbon has got isotopic forms, we will take the atomic mass of carbon 12, whose atomic mass is 12 atomic mass unit. AMU, which is abbreviated as U, it's 12U. One atomic mass is the mass of 1 by 12th the mass of carbon 12. That is the definition given for one atomic mass. One atomic mass is the mass of 1 by 12th the mass of carbon atom. The atomic mass of an element is defined as the average mass of an atom of an element compared with 1 by 12th the mass of carbon 12 atom. So atomic masses of some of the elements are given below. There is not a necessity to by heart the atomic masses when a problem or a concept is given. Usually the atomic masses are given to you. They are also available in the logarithmic tables. So atomic masses need not be by heart. So with that we end today's session. Please go through today's concepts and understand them clearly. Thank you.